k is the least positive integer, that is a square is not 0, a cube is not 0, up to k minus 1 it is not 0, but a power k is 0. Then once it is 0, all of you know a power k plus 1 onwards everything will be 0. Why is it so? Because a power k plus 1 is a power k into a power k 0 means 0 into anything is 0, and so on. So then we call such a matrix as a nilpotent matrix of order k. You can say in some textbook they call it index, or you can call it as degree, or you can call it as order, whatever it may be. So of index k we call it generally. So A is a nilpotent matrix of index k. This is the original definition. So if you take this, look at this question. I hope this is visible. If A is a 3 by 3 non-zero matrix such that A square is 0, then number of non-zero eigenvalues of A is. We want to answer this question. Is the question visible, sir? Nagesh sir? Nagesh sir?
Yes, madam.
Okay. If A is a 3 by 3 non-zero matrix, you are given A is not 0, such that A square is 0. That means A is not 0, but which is 0? First time A square is 0. First is the least. So first time when it is 0, we call this as the index. K is the index. So A is not 0, A square is 0. Once A square is 0, A cube, A4 will be zeros. What is the first integer for which it is 0 is 2. So we say A is a nilpotent matrix of index 2. Index 2. Now, this is nilpotent matrix of index 2. Then there is again another shortcut. You know what are eigenvalues? What are eigenvalues? That is, if Ax is equal to lambda x, there are 2 to 3 definitions. If you are able to find out a non-zero vector x such that Ax equal to lambda x, then lambda is called as the eigenvalue. X is what is called as the eigenvector. This is one definition. What is another definition is any value which satisfies this lambda value, which satisfies this equation determinant a minus lambda I, which is called characteristic equation, is called eigenvalue. This is another definition. So here if nothing is given, just simply we inferred that A is nilpotent matrix. Then we have a shortcut for a nilpotent matrix. So when I take up the topic, I'll give you all these shortcuts. So nilpotent matrix, the eigenvalues of all eigenvalues of nilpotent matrix will be always 0. Whatever may be the index. Some students, they may be thinking that because it is index 2, 2 eigenvalues will be 0. So if it is index 3, 3 eigenvalues, some intuitive feeling for the students. Maybe because order is here 3, 3 minus 2, 1 will be, eigenvalue will be 0. Like that, you are having some intuitive ideas. But the shortcut is, for a nilpotent matrix, all eigenvalues will be 0, whatever may be the index. How many eigenvalues a matrix will have? It is equal to order of the matrix. Because order is 3, it will have 3 eigenvalues. But according to definition, according to shortcut, all the 3 eigenvalues will be zeros. So how many non-zero eigenvalues are there? What is the question? Number of non-zero eigenvalues of A are. So how many are non-zero? All are zeros only. So how many non-zero are there? There is no non-zero at all, non-zero eigenvalue at all. Therefore, answer for this is 0. A option is the correct option. That means how many eigenvalues are non-zero? No eigenvalue is non-zero. All are zeros only. Therefore, 0 non-zero eigenvalues. So how many non-zero eigenvalues? There is no non-zero eigenvalue at all. Therefore, 0 is the answer for this. So how to handle this question? Suppose you are given this question. You learn generally in your academics what is nilpotent matrix, and you learn shortcuts separately, but you should infer, combining together. You should be able to infer. Here nowhere it is given as nilpotent. You have to infer it. This is application. So you should be able to correlate whatever you have learned, whatever you are going to learn in the class, to the question which is given in the question paper. The gap is, you have some knowledge, question is given, and you want to mark the options. This gap you should be able to fill up. For this reason only, you require some guidance through some institution or through some faculty. Okay, this gap I'll try to fill up. Okay, so A is 3 by 3 non-zero matrix. How did we infer? A square is 0. So suddenly the idea of definition of this nilpotent matrix should strike your mind. Then you inferred that it is a nilpotent matrix of order 2. Sometimes you may be given the bit, first bit. A is a nilpotent matrix of order 2. A is not a nilpotent matrix like this. That may also be given as option. But here we are not asked to do that. Then number of non-zero eigenvalues. Why it is given A square 0? Just to have confusion, because you can see options. So some students may answer 2. Why they answer 2? Because A square is 0. So they think maybe 2 eigenvalues are 0. Every option appears to be correct in the examination hall. So you should be very, very careful. So some students may answer 2. Some students may answer 3. Why the answer 3? Because A is a 3 by 3 matrix. How many eigenvalues are there? 3. They don't read the question properly. This non-zero, the term, if they miss, simply they read it as eigenvalues. Then how many eigenvalues are there? Order 3. Therefore, they write 3. 3 0 eigenvalues. 3 eigenvalues are there, but all the 3 are zeros. Some students may answer 1. Why they answer 1? Because they think, because index is 2, order is 3, maybe number of non-zero eigenvalues are n minus k. From where they get that intuitive idea, we don't know. But generally students, they get that intuitive idea in the examination hall. So just they write 3 minus 2, 1. Therefore, they think 1 is the correct one, which is incorrect. All eigenvalues are 0 for the nilpotent matrix. So how many non-zero are there? There is no non-zero at all. No non-zero means 0. 0 non-zero eigenvalues. Okay, this is the first one. Any doubts in this, or shall I proceed? Shall I proceed to next question? Are you able to follow first of all? You are able to catch my speed? Are you following first of all?
Yes, madam.
Yes, madam.
Okay, okay, fine.
Yes,
So
madam.
let us go to another interesting question. Here. I'll come to the remaining questions also, because we are doing for eigenvalues. I want to finish off that. The number of distinct eigenvalues of this matrix are. How many distinct eigenvalues are there? Previously, how many non-zero